and good day, geometry. We're starting Unit 2, talking about, well, basically, this is the unit where I teach you how to argue, how to actually logically and intelligently argue, because there's an art to it. There's an art to it. The reason why you've never lost and never won an argument against Professor Olson is because he's a master at it, right? But I'm going to arm you with what you need to do that now. So a couple of definitions to start with. A conjecture is an unproven statement based on inductive reasoning. And if you don't know what inductive reasoning is, it's a good thing it's our very next definition. Okay? But a conjecture is an unproven statement based on inductive reasoning. There are two types of reasoning. There's inductive and deductive. Inductive and deductive. Anyone know what inductive reasoning is? It's the less formal of the two, if that kind of helps. Kylie?
Is that like figuring out that?
Aiden?
I was going to say it has something to do with the counterexample.
Not really. No, I mean, no. That's not. They're related, but not in that. Not that way. So, inductive reasoning is a conclusion based on observations, judgments, and patterns. Okay? A conclusion based on observations, judgments, and patterns. Yes?
Is deductive reasoning based on actually doing the math?
Outside of the realm of math, deductive reasoning is conclusion based on evidence or facts or we cover that in CO13, so you don't need to know it quite yet. So basically, the difference is like when you walk into Spiel's room and you're like, "Oh, it's cold." That's because you observed that, right? In the court of law, you'd better have some hard evidence to support your client, otherwise you're going to be walking out of there with a verdict you don't really agree with, right? So it's very informal. It's like a snap judgment, versus deductive is well thought out and kind of you research things. It's not just doing the math; it's outside of the realm of that also. But first impressions, when you get a first impression of someone, that's inductive reasoning, right? You saw this, you react this way. Okay, and so conjecture is an unproven statement based on something you observe, a pattern, such as that. A counterexample is a specific situation which proves a conjecture false. A specific situation which proves a conjecture false. Okay? For example, there is no country in the world that starts with G. Germany would be, Greece would be the counterexample, right? It's if I'm reading through the list of countries, I might not see one that starts with a G. So based on my observation, there's no country that starts with a G. Oh, Greece, Germany. That's a counterexample that proved my unproven statement. It proved it false. Okay, folks. Damien, Joey, it'll cost you a pass. Okay. Will could go get. Oh wait, no, we can't.
That's gotta be so dumb. Just do your stuff in religion.
Yeah. So you're going for a pass? Okay. Questions on these? Questions on these definitions when he comes back. Questions on these definitions. Because when you do proofs, which is where we're headed, okay, it is very dangerous to use inductive reasoning. An example of inductive reasoning is in a proof is that, because it looks that way. This is a right angle because it looks like it, right? In geometry, it's unacceptable to make a conclusion because something looks like it. Just like you wouldn't want to go to the doctor and say, I've used this example before, doc says, we have to amputate. Why? Because it looks like it. No, you want them to do an x-ray. You want them to run some tests. You want them to be sure that what they're saying is what you actually need to do. Okay? Your client's guilty. Why? Looks like it. No, that's not how it's supposed to work, right? We do not want to be doing those inductive reasoning for those very serious things. Damon, you can go now if you want to flip on. Okay, so then practicing this a little bit. Damien, you're leaving the room. Please do it quietly. It says use inductive reasoning to form a conjecture about each situation. So without those terms, this sentence is probably really confusing. What am I using to form a what? Okay, you're using patterns, observations, to form an unproven statement, right, about the situation. The number of points, 1, 2, 3, 4, and 5, we've got a picture of connecting those points with connectors. And the number of connections is listed here also. Okay? Now, you can observe what's in the table to make a conjecture about how many connections there will be when there are 5 dots. Okay? And when I say that you can observe in the table, give me a couple different ways that you can observe this. Arlene.
My answer is 10 because I counted 10 and also 6 plus 4.
And why would you think to take 6 plus 4?
Because the pattern is, from 0 to 1 it's 1, then 1 to 3 is 2, and then 3 to 6 is 3.
Right.
And then 4.
So first she said, I observed, I just counted, right? If there's a picture there, you can just count, you can count 10. But then if I ask you for the number of points in with 6 points, number of connections with 6 points, here's where we move from the observation, just looking at it, to the pattern, which she also described, right? Adding 1, adding 2, adding 3, adding 4. Your conjecture is that next you would add 5, and there'd be 15. Okay? Who said what? The number of connections. The conjecture that we're making, both of these are. Okay? This first one, again, a conjecture is like just it's an unproven statement. It's kind of a conclusion based on observation. We observed that if there are 5 points, we can make 10 connections. Our conjecture is that there are 10 when there are 5 points, and there are, because we can count them, right? So then if there are 6 points, we can't count them because it's not drawn for us, so instead we have to use the pattern of adding 1, adding 2, adding 3, adding 4 to get 10. It would stand to reason that next we'd be adding 5, and there'd be 15 connections there. Okay? So both of these answers, they're called a conjecture because it's a conclusion that we've come to based on observation or pattern. Does that help, Catherine? Good. Kylie.
So with the connections, like what exactly is it counting? Because it's not counting the lines that are like drawn over them.
I believe it is. So like this is a connection here, and here, and here, and here. There's 4. And then 5, 6, 7, 8, 9, 10 would be the, like here, it's this is 1 connection, 2, and 3. Okay? Here, just the 1 connection we have is here. Right? The next section asks you for a counterexample to each statement. If the product of 2 numbers is positive, then the 2 numbers must both be positive. That's a conjecture that a 3rd grader might make based on their experience, based on their observations, first learning the multiplication tables. But then, of course, in like 4th or 5th grade, we say, Aiden.
What about -1 times -1?
Okay. A negative number times a negative number also results in a positive product, right? That would be a counterexample to this statement. Okay? That would be a counterexample to this statement. Next one, if the product of 2 numbers is even, then the two numbers must both be even, right? Oh, 2 times 6 equals 12, even product, they're both even. How about 4 times 10 is 40, right? Even product, they're both even. So if the product's even, the two numbers must also both be even. What? Why not? Joey?
4 times 3
Oh,
equals 12.
yeah. 4 times 3 would be an example of a counterexample, right? It proves that statement incorrect. You have an odd and an even number that still give you an even product. 1 times 3, that's. I'll edit that out of the video. I'll take that out. 3 times 2, that would work. Kylie, what are you gonna say? Sure. Yeah. Yep.
Anything times 1.
Not anything times 1, because like an odd number times 1 would still be odd. But all functions are a straight line when graphed on the coordinate plane. Going back to algebra, all functions are a straight line when graphed on the coordinate plane. Whoops. Oh yeah, that's right. Parabolas are curved. Bummer.
Wait a minute.
Yeah.
Oh, I didn't know parabolas were curved.
I feel it too, Anthony.
I wish I could. It's okay.
You know, at the end of the year, when you fill out your 8th grade memory book, you get to write in some of your favorite quotes from students and teachers. Can someone just jot that one down so you remember it in May? I didn't know parabolas were curved. Anthony. Favorite quotes from students and teachers. Okay. Okay. Raise your hand. What is an example of you using inductive reasoning to make a conjecture? What is an example of you using experience, observations, patterns to come to a conclusion based on that experience, observations, patterns? Jack.
Someone looks sick, you have to give them a prescription.
If someone looks sick, you wouldn't be able to give them a prescription, right? But they might need to go see the doctor. Okay. They might need to take some medicine. Yeah.
Did you just say parabola?
That wasn't the word.
Yeah, it was.
No, it wasn't.
Have a word.
Oh my God.
The whole class would have been exploding if it was. I don't believe you.
No,
I
it
don't
didn't
believe
happen,
you.
but Andrew said,
Yeah.
you said happy, we didn't even realize it until like a little bit later.
Shh. Arlene,
It's like,
Damien, one more time, and I'll ask you to leave the class.
it's like if someone notices that you wear ties every day, they think that you own a lot of ties.
Sure. Have you noticed I've worn the same tie for like 2 weeks straight now?
No.
Yeah, the exact same one. I was waiting to see if anyone would say anything, but I'm kind of bored of it.
Why didn't you say it? But it actually
I want to see if you observed it.
But it goes with your outfit.
It does go with my outfit. Black goes with everything. Okay.
Actually, that is not true.
I have, except for the day I wore the Mario shirt. Wow, okay. Another example of a conjecture, folks, based on inductive reasoning. Kylie. Sure. Okay. After maybe 2 weeks of school and a very small sample size, if someone has a low grade in class, you might make a conclusion. I have to be very careful about that as a teacher, right? Maybe you just had a bad test. You know, these 7th graders coming in, you know, I have these first impressions that I'm making of them, and I have to be careful to hold off on that because, you know, it's just so early in the year. Shh. Claire, quiet. Christopher. Sure. And even, you know, when you're planning your outfit for the day, if you plan on wearing shorts or pants or leggings or what have you, you may, you know, just open a window, look outside, stick your hand outside, see what the temp is. Just because it's sunny doesn't necessarily mean it's warm outside, right? But these things you are constantly doing, okay? Whenever you make a decision, that is a quick decision, you are doing it based on inductive reasoning. Hopefully, the high school that you are going to attend, Catherine, is not based on inductive reasoning. It's based on deductive reasoning, which we'll talk about in CO13. You've thought about it, right? Some of you are kind of lumped in based on where you live or your parents are telling you they're here. But hopefully, you know, colleges then, or trade school, or in the workforce, or whatever. Hopefully, you give that decision some sort of thought, right? So it's not just a snap decision. Okay, questions on any of this stuff? Okay, your homework. And look what I bought.
Being above.
You barely did anything.
Look what I have now. A teacher's edition.
Tight end.
Not a tight end. A teacher's edition.
Can I see that book when you're done?
You may not. You can buy one for yourself though. They're for sale. This was $50. eBay. eBay.
Does it give us the answers?
Gives me the answers, yeah.
Yeah, but if we were buying.
If you were to buy it, yeah, I'd give you the answers too. On page 75, you are to do 5 through 13.
1, 2,
3, 2, 1, you are quiet. Okay. Max, I counted down. Thank you. On page 75, 5 through 13 is your homework for tomorrow. Lexi, there might be one back there you can borrow, otherwise they'll cost you a pass. Okay. Hey, folks. Joey, warning for you. I counted down. Okay. Tomorrow, there will be a homework check instead of a bell ringer. So when I give a homework check, because I don't believe you've had one yet, there will be 5 questions taken directly from the homework, which could include things from the binder page or direct homework questions from your book. You can use your book. You can use the binder page. But if you don't get at least 4 out of the 5 homework questions correct, you're going to have to resubmit your form later on in the day if you want the point for that day in Blackbaud. This is my way of checking to make sure you understand the homework, not just writing down random answers. Okay? They actually get it. And if you don't get it, we'll go over it, so get the correct answers, and you have another chance to redeem yourself later on. So a bell ringer is different than a homework check. A homework check you are allowed to resubmit. It comes from the objective the homework is on only. A bell ringer, what you did today, is a one-time shot, and it is from anything we've done in the year. Okay? Shh. Homework check tomorrow. Okay, it's your first one, so it'll be a little bit lenient, but homework check tomorrow. You can use your book, use your binder. They'll only come from questions from this objective. Yes?
So like, if you retake it again, can you get the full 5 out of 5?
You only, a 4 out of 5 and a 5 out of 5 count the same. Okay? If you get less than 4, you need to resubmit, or you get a 0 out of 1. If you get a 4 or a 5, you get a 1 out of 1.
But if you like resubmit it, can you get like the full?
Yes, you resubmit in order to get the full credit. Okay? Kind of going in line with my theory that homework is just practice, I give you an opportunity to fix it if you didn't get it for when class starts. Yes?
Can I move spots so that I can use someone's book? She needs to go.
Noah's got you, sister. Okay? Lexi,
There's this full.
they're all gone?
Ask Jack for one. Jack can share with his.
All right, folks, that's our math.